So Unit 13, Day 1. And I guess I should show the calendar, which is posted in Schoology for you guys at home watching, so you can print this out or just reference it whenever you need it. 2 days on sum and difference angles. Actually 3 days on that, because tomorrow is also safety day. No school next Friday for Good Friday. That's nice. And our test is not until April 7th. So 2.5 weeks away. We built in 2 days for review because I get my second vaccine shot on the 5th. And a lot of people have the day after the second shot. It's been a wipeout day for them. So I don't know that if I'll be here the 6th. We'll find out when I wake up on the 6th and feel terrible. We'll see. All right, so Unit 13, Day 1, Sum and Difference Identities. Sum and difference identities. And we've used identities before. I just don't know that I've ever officially defined them. So an identity is a statement or equation that's always true. Usually involving variables, usually meant to illustrate some property. So like A times B plus C, well, an identity would be that's also equal to AB plus AC, right? That would be demonstrating the distributive property from long, long ago. Another identity that's a trig identity that we used is sine squared plus cosine squared equals 1. Doesn't matter what the angle is, that statement is always true. Doesn't matter what A, B, and C are, this statement is always true. So those are called identities. So we're going to look at some today that have to do with sum, so adding, difference, subtracting, with sines and cosines. And tangents even. So the next test will be open note. So write these down neatly and flag them so that you know where to locate them when it comes time. The sine of x plus y. Well, we already know, or I guess we could guess from the warm-ups, that you can't distribute sine. So it's not sine of x plus sine of y. That would have made life really easy if it happened that way, but it doesn't work that way. Sine of x plus y is equal to sine of x cosine of y plus cosine of x sine of y. It's like, yeah, what? Who came up with that? How'd they figure that out? I don't know the answer to that. But you're not going to have to memorize it because you'll have open notes with it. And if I remember right from previous years, this is one of those that we usually gave you these formulas anyway. So this is not a case of lowering the bar when we have an open note test, like most of the previous open note tests have been. Sine of x minus y. Well, if you had to guess, you'd probably guess correct, because the only thing that we changed was the plus to a minus. So the only thing we're going to change is a plus to a minus. So sine of x cosine of y minus cosine of x sine of y. So there's our sine identities. This doesn't really matter for you guys because you're not worried about memorizing them, but some textbooks will write that as one statement. They'll just put plus or minus right there and plus or minus right there, meaning that if you use the plus, use the plus. If it's minus, use the minus. But we don't do that very often, so I didn't want to. I thought that's more confusing than helpful. All right, cosine of x plus y. And again, you're not going to have to memorize these, so it's more about using them and fraction stuff we'll get to in a minute. Cosine of x, cosine of y. So we're already a little bit different than sine. Sine was sine cosine plus cosine sine. Cosine is cosine cosine minus, so there's another thing that's backwards. The plus goes to a minus. Sine x, sine y. Cosine of x minus y. Any guesses? Change that sign from a minus to a plus. So cosine x cosine y plus sine x sine y. Lastly, tangent. Tangent of x plus y. Well, you guys know that tangent's usually a little bit more complicated than sine and cosine, and that's the case here. Tangent of x plus tangent of y all over. It would have been great if that was the case, like if that was it, just distribute the tangent, but it didn't work that way. 1 minus tangent of x times tangent of y. And then tangent of x minus y. The only thing we did was change the plus to a minus. So the only thing we'll do on the other side is change the minuses to pluses and pluses to minuses. So 6 new equations today. Even if we required you to memorize them, it's really just 3 because of the plus minus switches. So it's not that big a deal. But it'll be open note, so you'll be able to reference these. So make sure those are written neatly and either starred or highlighted or whatever you need to do so that, you know, in 2 weeks when you're trying to find them, you can locate them easily. The trick isn't so much the formulas, because you'll be given those. The trick is breaking down this original argument. So question 1, cosine of 5 pi over 12. That's not a unit circle value, right? The unit circle is all over 2 and 3 and 4 and 6. There's nothing over 12 on the unit circle. So we'd really like to break this down or rewrite 5 over 12 as the sum of 2 things that we know, sum of something over 4 or 3 or 6. So here's another thing that you probably want to box until you get used to it. Let's write down those sort of basic unit circle values, and let's change them all to over 12. There's going to be a lot of over 12s today. So we're going to put them all over 12, and then we'll be able to figure out, well, how do we get to 5 pi over 12 using these? Now, some people, if they really think about it, they can get it from here. They don't have to write down what I'm about to write down. But first time through, let's put all of these over 12. Kind of a giant common denominator for everybody. And then it'll be easy to figure out who do we need to add to get to 5 over 12. So pi over 6 would be 2 over 12. Pi over 4 would be 3 over 12. This is what we did in warm-ups, basically, getting the common denominator. Top and bottom by 4, so 4 pi over 12. And pi over 2 would be 6 pi over 12. So that's another thing that you might want to box and have handy when you're trying to figure out, well, how did I get to 5 pi over 12? Well, for this one, it's not too bad, because it looks like if we add 2/12 and 3/12, that would get us 5 pi over 12. So I'm going to write that then as cosine of pi over 6 plus pi over 4. So the point of this lesson is to be able to get more sines and cosines that aren't on the unit circle, like 5 over 12, but using unit circle values by adding and subtracting things to get there. Let's see. So the rule for cosine with a sum. Oh, I don't want to underline that because then that looks like a minus sign. So cosine with the sum. So I go back and look at my formulas. So it's cosine of first one, cosine of the second one, minus sine of the first one, sine of the second one. Are you okay with where that came from? That was the fourth formula we listed. No, the third formula we listed. Cosine of the sum of cosines. Where pi over 6 is playing the role of x, pi over 4 is playing the role of y. Trying to match up where that stuff came from. Now that's 4 unit circle problems, but 4 problems that we should know. We should know what the cosine of pi over 6 is. Let's see, that would be root 3 over 2. Cosine of pi over 4. Over 4s are easy. Root 2 over 2. Sine of pi over 6. Well, I already had the cosine drawn, so I can use the same picture. Sine would be the y side, so that would be 1/2. And sine pi over 4 is root 2 over 2. Pardon? Yeah, and that's really similar to one of the ones we did in warm-up, which is why we did it in warm-ups, so that this part would go smoothly. So that's root 6 over 4 minus root 2 over 4. So I got my common denominator. What's root 6 minus root 2? Root 6 minus root 2. I can't do anything with those. So there's my answer. Now, this test will be no calculator, but while we're just practicing and learning, we could check to see if this is correct. So I'm going to plug in, I'm only going to do this on this one, but cosine 5 pi over 12 is that ugly decimal. And then square root of 6 minus square root of 2, all divided by 4. It's supposed to be the same decimal, so we'll see if we got this right. Yeah, same thing. So with a calculator, you can check these. On the test, you won't have a calculator, but for homework, if you do one that you think was kind of weird or you weren't sure that worked, it's easy to grab a calculator. Check the first statement with the last statement. They should match. Example 2. Sine of 105 degrees. Sine of 105 degrees. So I got to switch my brain over to degree mode, and I need to figure out how can I get to 105 using unit circle values, right? There's a lot of ways to get to 105. 100 plus 5, 104 plus 1, 50 plus 55. Like, those are all add to 105, but none of those are particularly helpful. So can you think of unit circle angles that would add to 105? What would that be? 60 and 45. And since it's adding, it shouldn't matter what order you put them in, so you could switch that order and be fine. So again, now we're referencing our formulas. We want a sine formula with addition. So that was the very first one we did. So sine of the first one, cosine of the second one, plus, vice versa, cosine of the first one, sine of the second one. Lots of unit circle today. Let's see, sine of 60, that would be root 3 over 2. Cosine 45, that's the one in the middle, so that's the easy one, root 2 over 2. Cosine of 60. Well, if the sine of 60 is root 3 over 2, then the cosine is 1/2. And sine of 45 is root 2 over 2. A lot of the multiplication and addition turns out to be really similar today because there's only so many values on the unit circle. So there's, again, a whole lot of root 3 over 2, root 2 over 2, and 1/2. So I'm almost out of space. I'm going to skip a step here. Root 6 plus root 2 all over 4. I'm not going to put this one in the calculator, but I could type sine 105 in the calculator. I could type all that in the calculator, and they would match. All right, sine of 11 pi over 12. 11 pi over 12. I'm going to rewrite. I mean, maybe you can figure out without writing them out. I'm going to rewrite them to figure out how to get to 11 pi over 12. So, again, that's one thing that you might have starred, so you don't have to think about it every time. Okay, well, I guess in some ways I can't get to 11 pi over 12, right? None of those add to 11, or no two of them add to 11. So is there a way I could combine? Because I'm allowed to use multiples of these, right? Like 2 pi over 3, or 5 pi over 6, or 3 pi over 4. So is there a way I could combine these? And there's more than one answer, so we'll see. How could I combine some of these to get to 11 over 12? Okay, so one way would be to add these 3, and that would make 11. So yes, that is true. If I added those 3, I would get 11 pi over 12. But why? My formulas all only have 2 numbers though. So you're not wrong. It's just not helpful if I try to add those 3 because I don't have an equation that adds 3 of them. So yes, I want to use multiples of them, not 3 different ones. So what were you saying, Andrew? What was the combination there?
You use 3 pi over 4 and then 1 pi over 6.
Okay. If I used 3 of these guys, that would get me to 9, and then 1 of these guys. Yeah.
You can also use 2 before and 1.
Okay, let me start writing these down because then I'm gonna get confused here. So Andrew's suggestion was 3 of these guys, because that would get me to 9, plus 2 would get me to 11. So I could do that. What was another way you saw?
I said 2 4 pi over 12 and 8 pi over 12.
Okay, so 2 of these would make 8, and 1 of these would make 11. So I could do 2 pi over 3 plus pi over 4.
Mine's simpler.
So, yeah, you can argue which one of those is better. I don't know. Like, it does. If you really struggle with the unit circle, and if you don't know one of those values, you can maybe like try to navigate around. You know, if you're struggling with the over 3s, then you could avoid that. So you're going to get the same answer either way. I'll go with, despite what this will do for his his self-worth, I'll go with Andrew's option, just because it was first. But you could do the other one, and you would get the same thing. All right, so the sine one is sine of the first, cosine of the second, plus vice versa. Whoops, put them in the right order that I wrote them. Cosine of the first, sine of the second. So that unit circle, unit circle, unit circle. 3 pi over 4 is right there. Sine would be positive, so root 2 over 2. Pi over 6 is that shallow angle, so cosine would be root 3 over 2. Cosine of 3 pi over 4. So it's over 4, so it's got to be root 2 over 2. But is it positive or negative? Negative, because it's in the second quadrant. And then sine of pi over 6 is 1/2. And again, you start to feel like you're doing the same problem over and over again, because it's all root 2's, root 3's, and 1/2. So root 6 minus root 2 all over 4. And in my notes, I had actually worked it the other way, but I got the same answer. So this is one of those places where if you're comparing notes with a friend, you might have different approaches and different in-between steps. Obviously, you should still get to the same answer. Right? In the interest of time, let's not work this one completely. Let's just figure out how we could get pi over 12 from unit circle things. So look at your equivalent fractions up here. You can definitely subtract, because there's no way to do it by adding, so you definitely need to subtract. So how do you want to get there? Cosine of pi over 12. So I'm trying to figure out how do I get pi over 12 from the fractions that I'm allowed to use. So Natalie, what did you say? So yeah, you could do pi over 3 minus pi over 4. Or you could divide, but we don't have a formula that handles division. All of our formulas right now, we'll do divide later, but right now we can only do adding and subtracting. So I could do pi over 3 minus pi over 4. I could do pi over 4 minus pi over 6. And yes, if you're trying to multiply them way out there, you could do them. You could do that, but then when you wrote the unit circle part, you'd have trickier things to deal with. So yes, it would work, but make your life harder. So you could go with either one of those. I don't want to do those because at that point you're just plugging into the formula. I do want to do the tangent problem because the math, the algebra part of it, is kind of a pain. So tangent of 5 pi over 12. First job is how do we rewrite 5 pi over 12? Any suggestions on how to get to 5 pi over 12? 5/12 out of these things.
6 minus 2 plus 2.
So you can get there crazy ways, or you can get there the easy way and just add over 6 and over 4. Again, if you want to take the crazy route, help yourself. It will make your life a little more complicated along the way, but you should still land at the same spot. So I'm going to use over 6 and over 4 because, if you really need to check it, that's 2/12 plus 3/12. So yeah, that's 5/12. All right, the tangent formula. Tangent pi over 6 plus tangent pi over 4 all over 1 minus tangent pi over 6 tangent pi over 4. So we got a lot of algebra coming on this one. Tangent of pi over 6. Well, the tangent 3 trick is that that's equal to root 3 over 3. Because over 6 has 2 3's in it, so it's root 3 over 3. Tangent pi over 4, that's an easy one, so we like that one. Right? What's tangent of pi over 4? 1. Well, sine and cosine are both root 2 over 2. So when you do sine over cosine, it becomes 1. Now, I'm kind of going through these fast, but if you need to slow down and work on those separately, then do that. Same values are in the bottom, used differently, but tangent of pi over 6, we said, was root 3 over 3. Tangent of pi over 4 is 1. So that's a mess, is what that is. Root 3 over 3 plus 1 over 1 minus root 3 over 3. So I got fractions and fractions, and I got a square root in the denominator. So I got to fix both of those things. To fix the fraction thing, that's easy. I'm going to multiply the top and the bottom by 3. That'll wipe out that denominator. So that'll fix the fraction and fraction part of this problem. So root 3 plus 3 over 3 minus root 3. So that's a little bit better. Do you remember how to fix square roots in the bottom? I need to multiply by something. And if I multiply by radical 3, I would have to distribute it. Yeah, top and bottom. But in the bottom, I'd have to distribute it, so it would fix this one, but mess this one up. So, good idea, on the right track, but it wouldn't work for this one.
You just multiply by whatever
No, because then I'd have to FOIL, and I'd get 2 square roots of 3 in there.
Is it 3 plus square root?
It's the conjugate, 3 plus square root of 3. So you were on the right track. You multiply by the conjugate of the bottom. And now you have 2 FOIL problems to do. So man, we're using all kinds of old school Algebra 1 work here. Most of you probably don't write out FOIL. First, 3 root 3. I'm going to write it out this time because I got 3's everywhere. Outside, root 3 times root 3 would be 3. Inside, 3 times 3 is 9. And last, 3 root 3. And I guess I could either FOIL the bottom or clean up the top. It doesn't really matter. I guess I'm in FOIL mode, so I'll keep FOILing. So in the bottom, 3 times 3 is 9. Outside would be 3 root 3. Inside would be minus 3 root 3. That happens every time you multiply by the conjugate. That's why you multiply by the conjugate, to make the square roots go away. So a lot of people, they don't show that step because they know that that's going to happen. And then the last one, this is what people mess up on. What's square root of 3 times square root of 3? 3. Now we just got cleanup to do here. So 12 plus 6 square root of 3 in the top. And in the bottom, 6. I can divide both of those by 6. It's all over 6. So I'll divide them each by 6 and get 2 plus square root of 3. That's definitely one that you might want to check on the calculator because that was a lot of work we did there. Tangent of 5 pi over 12. And then 2 plus square root of 3. It's supposed to be the same thing. And they are. So I know I did it right. All right, today's assignment is that worksheet 1. So 1 through 6, they already have it split up for you. 7 through 12, you're just doing some... Oh, you're kind of going backwards. So 7 through 12 is more about recognizing what's going on there. So 7 through 12 is a backwards problem. So cosine, cosine minus sine, sine. That's the cosine of x plus y. So that turns out to be the cosine of 25 plus 15. So that's what 7 through 12 wants you to do. You don't actually have to solve anything. You just have to recognize what's going on. And then 13 through 18 are the very similar to the ones we just did. All right, so give those a try. I'll post some answers in Schoology later. And then tomorrow we'll do something similar but with pictures.